Welcome to Daring Marana YouTube channel. Today we will be discussing about thermostatic expansion valve. So let's discuss about this in detail. Okay, the working of thermostatic expansion valve, it can be explained with the help of a image of a valve. The thermostatic expansion valve consists of external body in which various parts such as in this figure are enclosed. There are three pressure acting inside the thermostatic expansion valve. P1 is the pressure at the top of thermostatic expansion valve acting inside the power element above diaphragm. Due to this pressure, diaphragm tend to move down, due to which needle also move down and the valve tend to open. When the evaporator temperature becomes higher, gas in the feeler bulb will extend, due to which gas pressure inside the power element increases. This causes downward movement of needle to open the valve. Okay, here means working of thermostatic expansion valve with the help of that picture we will be discussing, and here there will be certain valves are there that is enclosed inside the body. There are three pressure acting inside the thermostatic expansion valve. There are three pressure acting inside the thermostatic expansion valve. That is P1 is the pressure at the top of thermostatic expansion valve. That P1 pressure is acting at the top of thermostatic expansion valve. That is acting inside the power element above diaphragm. That is acting inside power element above diaphragm. Due to this pressure, diaphragm tend to move down. Due to this pressure, the P1 pressure, diaphragm tend to move down, due to which needle also move down. When the diaphragm tend to move down, needle also move down and valve tend to open. When the evaporator pressure, that means when the evaporator temperature become higher, gas in the feeler bulb expand, due to which gas pressure inside the power element also increases. When the evaporator temperature increases, then there will be gas in the feeler bulb will also expand, which gas pressure inside the power element also increases. This causes downward movement of needle to open the valve. Okay, means here working of thermostatic expansion valve with the help of an image is there. During the thermostatic expansion valve, there are three valves are there that can be seen enclosed in it. There are three pressure acting inside thermostatic expansion valve. P1 is the pressure at the top of thermostatic expansion valve acting inside the power element above diaphragm. Due to this pressure, diaphragm tend to move down, due to which needle also move down and valve tend to open. When the evaporator temperature become higher, gas in the feeler bulb expand, due to which gas pressure inside the power element increases, and this causes downward movement of needle to open the valve. The pressure P2 is the pressure acting on the lower side of diaphragm, due to which the refrigerant pressure inside the evaporator. This pressure tends to move the diaphragm upwards and close the opening of valve. Pressure 2 means the pressure acting on the lower side of diaphragm, due to which refrigerant pressure inside the evaporator, and this pressure tend to move up the diaphragm and cause the opening of valve. Then pressure P3 is the spring pressure that tend to close the opening of valve. This pressure remains constant. Pressure P3 is spring pressure that is a constant that tend to close the opening of valve. Then pressure P2 and P3 act against pressure P1. Pressure P2 and P3 will act, that is downward pressure and spring pressure will act against the pressure that are acting on the top of diaphragm, that is P1. The P1 tend to open the valve, while P2 and P3 tend to close the thermostatic expansion valve. Okay, the pressure P1 tend to open the valve, while the pressure P2 and P3 tend to close the thermostatic expansion valve. If the valve has to open, P1 should be greater than combined force of P2 and P3. If the valve has to open, the P1 should be greater than combined force of P2 and P3. Okay, here the P2 is the pressure acting on the lower side of diaphragm. Due to the refrigerant pressure inside the evaporator, this pressure tends to move the diaphragm upward and close the opening of valve. P3 is the spring pressure that tends to close the opening of valve. The spring pressure is always remain constant. The pressure P2 and P3 act on the pressure P1. The pressure P1 tend to open the valve, while the pressure P2 and P3 tend to close the valve. So in order to open the valve, the pressure P1 should be greater than the combined force of P2 and P3. Here we can see P1 is there acting on the top of diaphragm, P2 and P3 on the bottom of diaphragm. P3 is spring force. Here we can see feeler bulb will be there, element, and two operator valve seat is there, valve needle, adjusting stem, maximum valve lifting, liquid inlet, push rod and all. Okay. During the normal working of refrigeration plant, thermostatic expansion valve remains closed in certain position. When the refrigeration load increases, temperature inside the evaporator also increases. In such case, there is need of more refrigerant to take care of the increased load. During normal working of the refrigeration plant, thermostatic expansion valve remains open in certain position. During normal working condition, refrigeration plant, thermostatic expansion valve remain open in certain condition. When the refrigerant load increases, temperature increases the inside the evaporator also increases. Okay. When refrigerant load increases, temperature inside the feeler gauge also increases. In such case, there is a need of more refrigerant to take care of the increased load. In that case, we need more refrigerant to take care of the increased load. The increased temperature in the evaporator is sensed by the feeler bulb of the thermostatic expansion valve. So this increased temperature is sensed by the feeler bulb of the thermostatic expansion valve. This leads to expansion of gas in the feeler bulb and also power element of thermostatic expansion valve, leading to increase of PV, increase pressure P1. Okay, so it means the feeler bulb will sense the increase in the evaporator temperature, and this leads to expansion of gas in the feeler bulb and leads the power the element of a thermostatic expansion valve, leading to increase in the pressure P1. Due to this, diaphragm of the thermostatic expansion valve moves down and tend to open the valve further to increase the flow of refrigerant to the evaporator. Okay. Due to this effect, the diaphragm will of the thermostatic expansion valve will move downward and tend to open the valve further to increase the flow of refrigerant against the evaporator. Okay. During the normal working of refrigeration plant, the thermostatic expansion valve remains open in a certain position. When the refrigerant load increases, the temperature inside the evaporator also increases. In such case, there is also of more refrigerant to take care of the increased load. The increased temperature in the evaporator, it is sensed by the feeler bulb of the thermostatic expansion valve. This leads to expansion of gas in the feeler bulb and also in the power element of thermostatic expansion valve, leading to the increase in pressure P1. Due to this, diaphragm of the thermostatic expansion valve moves down and tend to open the valve further to increase the flow of refrigerant to the evaporator. At the same time, the pressure P2 below the diaphragm also increases due to superheating of the refrigerant increases the evaporator. This pressure tends to close the valve. There is also spring pressure below the diaphragm that opposes the opening of valve. If the increase in the refrigeration load is much higher than pressure P1 overcomes the pressure P2 and P3, leading to further opening of thermostatic expansion valve. This allows for the increased flow of refrigerant to evaporator to take care of the extra load. Okay, what is happening is at the same time the pressure P2 below the diaphragm also increases due to superheating the refrigerant inside the evaporator. So the pressure tends to close the valve, and there is also spring pressure active below the diaphragm. So they also tends to close the opening of valve. So if the increase in the refrigeration load, that is if a pressure P1, if it overcomes the combined pressure of P2 and P3, then it will open further opening the thermostatic expansion for a certain period of time, and this allow increased flow of refrigerant to the evaporator to take care of the extra load. When the refrigerant load is reduced, magnitude of pressure P1 will reduces and the combined pressure P2 and P3 overcome the pressure P1, that allow for the partial closing of valve so that flow of refrigerant to the evaporator reduces. Okay, when the refrigerant load reduces, the magnitude of pressure, that means P1 reduces, and slowly then gradually the other two pressure P2 and P3 will be combined pressure will be increased. So that allow the partial closing of the valve so that flow of refrigerant to the evaporator reduces. Thus, thermal expansion valve maintains the flow of refrigerant inside the evaporator as per refrigeration or air conditioning load. So by this method, thermostatic expansion valve will maintain the flow of refrigerant inside the evaporator as per refrigeration or air conditioning load. The thermostatic expansion valve constantly modulates the flow to maintain the superheat for which it has been adjusted by the spring. The thermostatic expansion valve so constantly modulates the flow to maintain superheat for which it has been adjusted by the spring. Okay. When the refrigeration load reduces, the magnitude of pressure P1 reduces and a combined pressure P2 and P3 overcome the pressure P1, that allow for partial closing of valve so that flow of refrigerant to the evaporator will reduce, and thermostatic expansion valve maintain the flow of refrigerant inside the evaporator as per refrigeration of air conditioning load. The thermostatic expansion valve constantly modulates the flow to maintain superheat for which it has been adjusted by the spring. Thank you.